Our world is changing, and our world needs new, because new doesn't just think about the world's problems, it cares. New acts boldly to solve challenges, but never forgets the importance of people.
New Zealand is a socially progressive country and it's really inclusive.
New is prepared for today and ready to create tomorrow.
Qualifications in New Zealand are recognized worldwide.
New welcomes open minds and different perspectives.
All of the teachers have been super supportive.
New is progressive and never stops learning.
It just opens my eyes to a much wider opportunities.
New is the problem solvers, the go-getters, the innovators, the big thinkers. New is a New Zealand education, and new is what the world needs.
Hello, my name is Heitor Gomes, and I'm very pleased to be here to give you this masterclass entitled The Dawn of Machine Learning for Fast and Evolving Data. Before we get started with the class itself, I need to introduce myself. So, as I said, I'm Heitor Gomes. I was born in Brazil. I was living in Curitiba for 27 years. I have a PhD in computer science from the Pontifical Catholic University of Paraná. Currently, I'm a senior research fellow and head of the MOA lab at the University of Waikato in New Zealand. But before that, I have done several things. For example, I was a Java developer once. I also worked with SAP. I was a CS lecturer, iOS developer. I started a company. I failed a company. I did a postdoc in Paris. And finally, I was a Kung Fu instructor, which was not the most well-paid job, but was one of the most fulfilling ones. In terms of research, as you might imagine, I do a lot of research on machine learning. I work with data streams, which I hope to introduce you to the concept today, ensemble learning, semi-supervised learning, and distributed machine learning. Several other topics you can find on my website, this one here below. But don't go there right now, like stick with me for at least more 25 minutes. So before we talk about fast data and how we apply machine learning to it, what is machine learning? That's, it's a very famous topic right now. Like a lot of people are talking about it. Some people are applying this in practice, but what is it? So is it the same as artificial intelligence? Well, not really, because artificial intelligence is a more general term. Like there are some other research areas that maybe are not as popular as machine learning right now, but they are still there. So we cannot say that they are the same. Is it an attempt to make machines self-aware like we see in the movies? Not really. Usually what we want to do with machine learning is more pragmatic. Like we want to solve some really some tasks that are really easy for humans, but are very difficult for computers. So we want to automate these tasks. The 99% of the time, this is what we are trying to achieve. If we were to make a definition of what is machine learning or what it means to learn in this sense, we have this very formal definition from Tom Mitchell. I'm not going to read it out loud. We can have a simplification of it. Like we have, what is it? It's a teach a computer program how to solve a problem by showing it examples. Let's try to decompose this sentence a little bit. So what are the examples? They are basically the data. So whatever I show my algorithm is the experience or examples that it's going to use for making, for building a model out of that data. The teaching part is analogous to creating this model. So we have an algorithm that looks at this data and creates a model of it to solve a specific problem. That's also important because some people think that we can use machine learning. We can, maybe in the future, we can use it like to solve general problems, but usually it's focused in one specific problem. Now let's make an example, like a more compelling example using cats and dogs, because well, that's that's what I usually like to do for a start. Now, don't worry about the cats and the dogs. They are fine with me showing their pictures. I know all of them personally, especially the dog. Um, so, what is if we were to use a very simple example of supervised learning, which is a area of machine learning? We give some training data. So we have these figures, these images here of cats and dogs, and we have a problem that we want to solve. The problem is I want to give an image to my model, and the model will tell me if it's a dog or a cat. We call it supervised because we have supervision in this task. So I show the image to the algorithm, and I also show it the label, like it's a dog, and then I show it a dog. So it can more easily learn to discern between the two classes in this case. Now, and the whole process, like in a overly simplified version, is we give this data to the model, we build the model, we use the model to make predictions. Usually the predictions are made on a new data set, like a separate data set. It should be not the same data set as the training data. And often this test data or the real data that we use afterwards is much more challenging than the data that we use for training. So yeah, we need to find a way to build a good model, even though we are not really sure what is coming afterwards. Okay, so that was a very brief introduction to machine learning. What about fast and evolving data? What do I mean by that? So here, if I were to put in a single slide, the difference between having like fast data on your right and on your left, we have this offline or traditional way of doing machine learning. In the traditional way, we have this static data set. And well, this slide is a little bit boring, so let's make it much nicer. So in this side here, we have all the images of the cats and the dogs, and I want to build the model for, discerning between both. And the algorithm has access to all of it at once. It can go like iterate several times through the same data. In this case, in a fast data or streaming data scenario, the images, they are arriving over time. It could be images or some other kind of data. The important thing is that we have this this continuous flow of data coming in. And what happens is that we cannot store all this data before processing it. We cannot do several things that are possible in the batch scenario or the static data scenario. We need to deal with other kinds of problems, like not only building the model, but also keeping it update, also taking care of changes and so on. So summarizing this, when I'm building this data, this model on offline data, I have a very well-defined training phase, and then I have a test phase to verify how good is this model before I put it into production. And the output of this whole process is a trained model. And this trained model, if you are familiar with computer science, it kind of will look like a function sometimes, that you have like a function with some hard-coded parameters perhaps, that you are always going to call when you have to predict like you receive a new image and you want to predict if it's a cat or a dog or any other problem. Now, in the streaming scenario, this is a little bit different because the training and the test phases, they are interleaved. There is no clear definition when the training ends and the test starts, or when we actually are making actual predictions, like in practice. So the output of this process is a trainable model, which makes things a little bit harder because it's not a single function sitting on a server there. It's like actual code being executed because it's being updated, it's learning, and it's basically doing the training process on the fly. There are several challenges that this streaming data setting entails. The first one is, as you might have imagined, fast data. So we need to generate the predictions and update the models without any delays. It takes a very it may take a very long time to build a model in a static or traditional setting. And in here, we do not have this possibility to take too long to do it, because we need to do this on the fly. Often, every millisecond, we need to keep the model updated. The second challenge, which is a very classic problem on data streams, is that the data distribution may change over time. Like, we don't know what is the data distribution, because if we knew, we don't need machine learning. And also it may change. So whatever model that we build at one specific point in time, it might be outdated in the future. And we call this this process, like when this happens, we call this concept drift. So let's have an, I don't know, easily, no, sorry. Let's have an example of this concept drift in using terms that you might be familiar with, if you're not familiar with machine learning. So suppose we have a grocery store. We sell goods in store and we sell some over the internet. Life is good, everything is going fine. I have like maybe 90% of my customers, they come in store, and some people order online. But then 2020, if you were around last year, you might know that some things changed, like really abruptly. From one day to the other, people were forced to stay at home, and then we cannot have the same model that we had before. I'm not talking about machine learning model, like thinking about the business model that some companies were had at the time. So after that, we moved to, we sell goods in store and some over the internet, to we sell goods over the internet. Perhaps like the in-store experience is lost for some specific companies, and then they need to adapt to it. Well, what is the implication of that for machine learning? And there's this very interesting article in TechCrunch about how to diagnose and treat machine learning models afflicted by COVID-19. And when you see machine learning and COVID-19 on the same sentence, you might think like, oh, perhaps they are talking about using machine learning to model how the virus will spread in a specific region of the world, or something like, is this patient going to evolve to a bad case of COVID-19? But in here, what we are talking about is how do we diagnose the machine learning models. So we want to have a way to improve these models, or we want to have a way to recover from the changes that happen. Let's go back to the grocery store example. Like if I had let's say a machine learning model that models how my customers behave after 2020, this model has to be updated, because otherwise it will start making a lot of wrong predictions, a lot of wrong recommendations. And this is just one example, and you might think like, well, this is not that serious. We can sustain maybe 2 or 3 months of incorrect predictions. Yeah, depending on the problem, yes, but machine learning is very pervasive nowadays. There are like many companies that use it. So it's not only for like providing you recommendations on, oh, if you are buying a desktop, probably you want to also buy this mouse. It's also giving you, like, for example, if you are going to receive credit or not. It might be very important to have an updated model that is fair and that is not like going to make a misclassification and then going to cause a huge economic problem for some specific parts of our community. Okay, so that was the general example. Now I'm going to move to a more technical example using this very simple classification problem. So assume we have these two classes and I have only two features, because then I can plot them in a 2D screen very easily. And my goal is to create a separation such that I can classify these red ones on the top and I can classify the blue ones on the bottom, like accurately. Luckily, it's very easy to do for this example, because we can build a very simple linear model to separate them. We see two mistakes here, but that's all right. We can say like they might be noise because they are too close to this border. And well, once again, life is good. I have my model. Everything is going all right. If I have a new instance here on the top, it's going to be classified as red. If I have a new one here on the bottom, it's going to be classified as blue, and so on. The problem is when this changes, like the data distribution shifts like this at time t plus delta. After this shift, like we are not looking at the same data, it's like a data generated maybe 1 week after this one here, this initial time t1. And we have to, we can see that it's not like really performing very well anymore. So what can we do? What can we possibly do in this case? One approach is to detect such change and to adapt to it. Well, or you can continuously adapt to new data. There are several techniques. The problem is we don't have much time to go through it, but I hope this was at least a good start for you to start investigating it if you are a researcher or if you are someone looking to work on industry to see the benefits of such algorithms that do this detection and this recovery. Now let's shift very quickly to a completely different topic. This is a concept drift that I just made. Let's talk about some birds. You might be asking yourself, like, why he's talking about birds? If you know the University of Waikato, you might have an idea of why I'm doing that. So here, this little fella is a weka, and it's a very tiny bird. It still exists nowadays. This big fella here is a moa. Unfortunately, it's extinct right now. So the reason I'm introducing you to these two majestic birds is that our frameworks here, like two of the main frameworks that we have built at the University of Waikato, one of them is Weka. It's an open source machine learning software. It was open source when it was not cool to open source things. It was like in 94 when this started. So it was the first workbench for machine learning where people could, people who were not familiar with computer science, they didn't have to go through coding or everything to use it. So it was very popular. Now it's not perhaps as popular as it used to be before because there are so many other platforms to use it, but they still use it for teaching, research, and some industrial applications. Now this is Weka. MOA is the what I can say, it's the most popular open source framework for data stream mining. It was built 10 years ago, like when it started. Actually, more than 10 years ago, I'm getting old. It's like 15 years ago. It has a very active growing community. It's kind of sibling of Weka. So even though it's bigger, it's the younger brother of Weka. And the focus here is not traditional machine learning, it's actually machine learning for data streams. There are several algorithms there, I believe more than 400 algorithms, and so it's the largest collection of data stream mining algorithms. The graphical user interface of MOA is a little bit similar to Weka, so if you're familiar with it, you can also use it from the command line, you can use it on Jupyter notebooks. It's developed in Java. It's very easy to extend if you want to integrate this into another piece of software. And here is the website for MOA if you are interested in using it. It's open source, so you can change it, you can use it as long as you respect the license. We also have a book on MOA. So this is the MOA book. We have several examples of how to do it. It's free access, so you can buy, you are welcome to buy the book and have the hard copy of it, but you can also have the free access of it. We made sure to open source the book as well. So if you go to the website, to this book HTML, you can navigate through the whole book for free. Now, finally, we have the MOA Lab. So the MOA Lab is part of the AI Institute, which I will introduce you in the next slide. We have several students, like honors, master students, and 5 PhD students at the moment. We have our research focus is machine learning for evolving data streams. We use MOA. We also use some Python tools that are developed in-house. The Mo website is under construction. I became the head of the lab literally 1 week ago. So we are making some changes to how the website looks and what are our goal. The AI Institute, which was officially launched 2 weeks ago, you see that things are very recent here. In terms of structure, so we had like a lot of restructuration inside of the university, and the goal of this institute is to build awareness and expertise across disciplines so we can better leverage AI for the benefit of our communities. So this is not only machine learning, it's also more broad, so it incorporates like several other labs. Like we have the MOA lab, but we also have the machine learning lab, the applied machine learning, and robotics, and several others. And here's the first version of the website, which is still under construction because, 2 weeks old institute. The labs, they are like 20 years old, like the machine learning lab maybe started in the 90s, and the applied machine learning in the maybe 95 or 98 or something. But the institute as a whole, like combining everything, is more recent. Some opportunities for you if you are not very familiar with computer science, or you are more you want to have a career focused on developing applications, not necessarily machine learning. We have this Masters of Information Technology, the MINFOTech, at the University of Waikato, that you can benefit from. Several students from abroad come every year to work on this. I have supervised some students from this, and it was a very nice experience because they get to work on a company for 10 weeks, and after that, all of them are employed in some company around. Some are doing data science, some are doing programming, some are doing designing and other stuff. Next year, we'll have a master's in AI from the AI Institute, but it's not released yet, so you are probably the first ones to hear about it. We have PhD scholarships at the University of Waikato. You need to look at the webpage for this. We have PhD scholarships as part of funded projects. You will need to look at the AI Institute webpage for that, which the information might not be there yet, but in 1 week from now, we might have more information about it. And every now and then we will post more information about scholarships. Finally, thanks a lot for attending. If you are interested in the topic and you are a researcher, here is a recent survey about the challenges and some of the things that I talked about today, and much more details about other things in this paper. If you are a researcher and you want to connect, just leave me a message. Here is my website, and thank you. I think we can now move to questions. I would just stop sharing my screen and look at the chat. Okay. So Talita. Okay. So first question. I will read this in English. This is in Portuguese, but I can read this in English. How do programming cookies works for streaming platforms? For example, Netflix recommendations based on what you do and so on. That's a very interesting question. It's more application specific, so I don't know exactly how they do this on Netflix. But one thing that you could possibly do is that you store some information about the user. You don't really need to use cookies in this case, if it's Netflix, for example, because they know a lot about your navigation already, so you don't need to store it. It's just an online recommendation system. And this is also interesting because you can have some offline model, and you have some new things coming in, and depending on what you click and what kind of movie you watch, the kind of movie that you stop watching in the middle, you learn something about you learn more about it. Okay. Next question. New Zealand. I don't understand. Sorry, this is in Spanish. I cannot. I don't understand it. We need to move to the next one. So, guys, I can read Portuguese and I can read English, but in Spanish, sorry, I can't. Okay. What it means delay. Okay, so delay is if we are talking in the context of making predictions and updating the model, we assume that the data is always coming in. Let's say that every 1 second I have a new image. And if I take 3 seconds to update my model, there will be 3 images coming in, and I just updated the model based on one of them. So this delay, it starts to create a queue of images, and then at some point we run out of memory because we are not processing the information as fast as it's coming in, or we start to throwing away the images, which is also bad. So that's the meaning of delay. Okay, thanks a lot. I think that these were the questions. See you next time.